We are going to work some applied Newton's law problems that involve spring forces. I'm going to start by reading the problem and writing down the obvious things that I'm given. So I'm given a force constant, that's K, and I'm given a mass, and I'm going to note that I'm given that mass in grams. I am going to straight away convert that mass from grams into kilograms because I want to be dealing with everything in SI units, and it's easy to forget a conversion like that. Okay, and what am I looking for in this problem? How far in centimeters will the spring stretch? At this point, if you can identify the variable or letter that we use to represent that, how far will the spring stretch, it can actually help you pick the correct equation. Since this is a spring, I am probably going to want Hooke's law, which relates the force to the spring constant and the amount that a spring is stretched or compressed. Let's sketch it. I'm going to draw kind of the before and after, the spring with no mass and then the spring with a mass. All right, so with the mass on there, delta x will increase. The amount of displacement of the spring from equilibrium will increase. And the F in my Hooke's law equation there is actually the restoring force, because the spring that's been stretched wants to get back to equilibrium. What is causing the spring to stretch? Well, it's the weight. The force that's acting down that is caused by the mass. So mass times gravity, and note that is a downward force. So I am going to have negative mg, and it's negative because the weight acts down, equal to the positive restoring force. But when I write my equation, there's a negative sign there because the positive restoring force equals negative k delta x. Solve that for delta x and sub in my given values. Do not forget that this problem asked for the answer in centimeters. So that means I am going to need to convert from meters to centimeters.